Okay, this is the latest version of the jetting calculator, and I want to go over just a few points about using it. In this little cell right here, you can enter Y or N for yes or no concerning whether or not you have a racing expansion chamber. If you have like a really long baffle, like more than 6 inches, or you have just a header and a muffler, of course those are not racing. Um, This right here asks whether or not you have the best wide open throttle jetting, which means that uh, when you ride the bike at top RPM for a while and then you take out the plug and you look at it and it has a nice tan or a nice chocolate brown color, that's good. That's good. That's good jetting, but that's only the wide open throttle, which is why this program exists. It helps you to figure out everything else. So if you if you achieve that, you dialed in the main jet, put a Y right here, and then with everything else that you enter, this being very important out here, which is the height of the slide. When the needle starts to be exposed at the beginning of the taper, it's explained on my site. So all these light blue cells, you enter all that information in. And then you take this number right here, which in this case is 0.63, and you enter it right here. That stores it, okay? So then any other changes you make on the needle, on the needle jet, on the clip position, anything else, it'll still remember that as the ideal top throttle setting, jetting. So this is the ideal, um, the gray graph. The blue graph is what uh, the program is telling you what the jetting is from 1/8 slide open to fully open. And the red graph is the difference between these two. And this black graph um, is the effective jet flow area for both the needle and the main jet because they work in conjunction. What you heard was a very gross oversimplification about the needle jet controlling the mid-range completely and the main jet controlling the wide open throttle and 7/8 inch throttle and whatever that is, 3/4 inch throttle. They overlap. The main affects all the way down here and the needle affects all the way up here. Even though this area is mostly the main and this area is mostly the needle. Okay, so like I said, the red's the difference between these two. And so 1.0, this one right here, is perfect. Anything above that is rich, anything below that is lean. So I've got, this is my motorized bicycle engine, the specs for it. And I've got two really good needles for it. And this needle is best right now because I've got a very slight crank seal leak. And when you have a crank seal leak, you have to compensate for it with rich jetting. So from the very start, and then it tapers off as you go to top throttle setting. So this is good. But once I get that seal replaced, I'm going to move back to this needle. And go a little bit higher on the main. And go a little bit leaner on the idle. Okay. Once that seal is corrected, I want it to hug that gray graph as much as possible. This is almost 1.0 all the way across. Okay, so that's a good example for the Makuni VM. Let's look at Keyheim. In this example, it's too rich, starting at 1/4 to about 5/8, a little bit beyond. So what we've got in there right now is if you, this is the needle ID, DEK. If you scroll over here, you can look up what that means. D gives you a taper degree of 1 degree and 45 minutes, which is 1.75 degrees. E gives you a length of 36, and K gives a straight shaft diameter of right almost 2.7. So this is very important. This has to be long enough for the carb that you're using, and this is very important. I'm going to show you why. This right here, this percentage right here, should always be around 30%. And it is the ratio of the spacing between the needle and the needle jet, and when the slide is closed, so it's just the straight portion of the jet and the needle jet, compared to wide open throttle jet flow area. If it's too high, it means your needle is too skinny, and if it's too low, it means your needle is too fat. Or the reverse. It has to do with if you can change the needle jet size, also you can manipulate that. This right here is interesting to watch, because if that's not a nice curve, it might indicate that the needle is kicking in too soon or too late. I want to show you what happens. Right here it's saying it's kicking in at 4 millimeters slide open. Let's change that to 6 and see what happens on the graph. Oh, that's nice. Okay, so now we've got a variation between a little bit too low, a little bit too high. That's okay. You know, if you're within 5/100ths of that, that's good. So if we went in the other direction, yeah, you can see how this gets fat or high very early. That's because the needle is kicking in very early, because this is very low slide of 2 millimeters when it kicks in. So you can manipulate this curve just with that, and that's your needle clip position. And if you find something really ideal here that you can't fix with a cutaway or the needle or anything else, but the mechanical aspects of your slide and the needle do not allow it, you can fix it. You can make your own little plastic washers that you can fit under the needle clip, or if the needle needs to go lower, you can use a Dremel to lower the base that the clip sits on in this slide. So that's the DEK, and it likes, what did I say? It likes 6, okay? Another good option would be going with the BEK, and it's going to go haywire. You see all that? All the numbers disappeared, the graphs disappeared, because when you enter an ID here that is not one of these that's listed down here, it has to be also listed right here in one of these 3 in the correct section. In this case, it's this section right here, so it's BEK, and everything goes back to normal. Your graphs normal. So now you see the jetting is a little bit lean at wide open, so we'll increase the main jet to fix that. And we can have the needle kicking a little bit earlier. Let's set that at 4. And this is just, to me, this is slightly better than the previous one, but they're both pretty similar. But this is just giving you an idea how to manipulate the things that you can change to get a perfect jetting graph. Let's look at Del Orto. Okay, this is going crazy. So we've got too lean right here, and then we've got too rich right here. And you can see by the little kink right there, that needle is kicking in too late. But if I make it kick in early, this is going to go even fatter. So when you have an imbalance like that, it's probably best to in this case, to bring that kink even a little bit farther. I'm going to do that. I'm changing that to 6 millimeters. Maybe a little bit too much. Let's do 5 millimeters. So now you have a balance between the too lean and the too rich. So let's try a different needle. This is the K41 on Del Orto. We don't, unlike with the Mikuni and the Keyhine, I do not have the needle specs down here for the program to read. One of these days I might get around to it, but right now it's just too big a task. So if you go to my website, you can find the Del Orto page. And on that page, it will tell the atomizers available for the different models, and it will list all of the needles. The advantage to looking at my site for these needles is that the angles are listed also. I entered in all these numbers into my calculator and got all the angles. That was step number one. So just at a look, you can get an idea what you're dealing with. And this right here is a dual taper. For the PHBG, they're all single tapers. This is the carb we're dealing with right now, and so I'm going to try X48, I think I said, which is down here. This right here is the straight shaft diameter. So when the percentage right here is too low, like in this case it's too low, it's 18%, you want that shaft diameter to be smaller. So right now we've got 2.48 millimeters, and unfortunately I couldn't find a needle that goes very much lower than that, so we're going to have to raise the or put a larger needle jet in it, which will also on this page it shows right here what they call the needle jet an atomizer. So on the PHBG it uses an AU. There might be others that fit it also. This is not complete. So PHBG, okay, so the atomizers range from 2.62 millimeters to 2.66. Let's see what we've got in there now, 2.64. Okay, I'm just going to change that to 2.66. Which brought it up to 24%. Okay, I'm going to put a different needle in it. X48. And the data for X48 on my website is 2.47 shaft diameter. The tip diameter is 1 0.8. When you go for the dual taper needles, you'll fill in these two also. When it's just a single taper, those go to 0. Okay, the length of the taper is 29. Okay, so right off the bat, I'm going to need to increase the main jet. I'm going to bring this kink a little bit to the left by making this smaller. Okay, so that gave me really good agreement there. A little bit rich here, so I'm going to go down on the main. Voila, that's nice. Okay. Okay, so anyway, we've got the old carb section here. This is for any carb that is not Mikuni VM, TM, TMS, TMX, Keyhine, or Del Orto. And I just call it the old carb jetting calculator. You can put a Bing in there, you can put an AMOL, you can put anything you want, but you've got to measure everything. The hardest thing to measure is that jet hole diameter. You might have to twist some solder together, put it in until it finally matches that hole, and then measure the width of that solder. Everything else is just digital calipers you can measure easy enough. Another thing really hard to measure is the idle jet. Those holes, some small carbs are just so small. What I would do is just put everything else in here and then just change this until the blue and the gray match right here, which means it idles right. Of course, you got to make sure on the real motorcycle it idles right. Please refer to my site for what I mean by idling right. And this uses the same scheme that the Del Orto uses, with the shaft diameter A, the tip diameter B, the taper length C, and then if it's a dual taper, you can also do D and E, which on my site is, where is that? Right here. This right here explains all the letters. So, of course, all of these need to know the maximum air velocity, and you get that on the last sheet. You enter the engine size, the transfer duration. If you don't know, just leave it at 124. It's not real critical. The maximum RPM, if you don't know that, one of these two will tell you. If you know the crank rotations per wheel rotation, yep, put it in the gear in which you were testing and take the spark plug out and put a screwdriver in and feel every time the piston goes up to hit that screwdriver. And put the bike on a stand and rotate the rear wheel. When that rear wheel makes one full completion, the number of crank rotations will be the number of times that the piston hit the screwdriver, and you put that number out here usually. And you have to know the maximum kilometers per hour or maximum miles per hour. And so this will tell you what the maximum RPM is, which you'll put right here, the carb size, and then right here is the carb air velocity in meters per second. This is what you use in the other sheets. And this also tells you what the perfect carb size is for trail and street use and for racing use. So that pretty much covers it. If you try one needle and you want to record it, just click on the record button down here, and it'll put it all down here. This is an error right here, which I'm going to fix. Okay, that's about it. Thank you so much for watching.